Okay. Recording? Okay. So, we need to try to figure out what's going on with this math. So we got this cluster size. So then we might want to know what SI is, right? So what's SI, right? Well, some of these are going to be pretty obvious, right? So it's like, right, we could just print these all off, right? So, printf. Okay, so we have enough information where hopefully we can glean some type of insight as to what is wrong with our formulas. It's really annoying how our formulas are like getting really close, but then they're like off by one or off by a lot, or I didn't think a mapping formula would be this difficult. So we need to looks like we're gonna keep this float thing here, so check your math. Let's create a check your math section, I guess. So we can put this macro here, right? So define f as this float32 maker macro. And then in here we can indent this. And then actually no, we don't want to indent that. We were close to what we wanted to indent, but not, that wasn't quite right, was it? It was we want to indent this whole thing. Right, because this is all within that section. So check your math. And now we just want to undef f. This is the end of a section, so we want to put it over here. Okay. Argument has type double because we converted things to float, right? So this is actually floating point. This is floating point. This is also floating point. These are all floating point. What am I doing? They're all floating points. Okay. So let's see what those look like and try to get an idea of like why the heck is our I don't know. Like, this is kind of annoying. Like, I wouldn't expect to be spending like a whole week on just trying to map a fucking range. So it's 112 to 112. So the cluster size is 1, right? It's a 1-to-1 mapping, is what that's telling me. And if the cluster size is, oh, hey, there we go. So this definitely gives us a cluster size, and that's good and everything. However, this division here, needs to be zeroed out, right? This index needs to be zeroed out, right? So, yeah, that index needs to be zeroed out, and then I think we're good, right? Because, yeah, it just needs to be, that index just needs to be zeroed out. So D0. So we do D0, or not D0, but S0, right? So I thought we were going to have to, like, minus somewhere else. So, right, this index is on the range. It needs to be zeroed out, so it's on the range. So I was seeing that some things weren't working because they were, they didn't seem to be on the correct ranges here. So let's see if our math now works, right? Because if it doesn't say check your math, then we're in good standing, right? So yeah, no more check your math there, right? Just back here, right? So, or hold on. Yeah. Oh. Go identifier. I don't know, let's just try to make this unique. $2021. Yeah, so I'm pretty sure that over here, all we gotta do is we gotta zero out these ranges, right? So this needs to be minus, this range needs to be, we gotta take the source zeroed out range. So SX0, right, to zero that range out, and then same thing with the Y, SY0, and that gets zeroed out, right? So SY0, before we turn it into floating point, we gotta zero it out. So SY0, SX0, these things down here. So now what we're hoping right now is that right now we're failing on meta group number 1. We're expecting that if we give this another run, that function will pass everything and it'll be good times. Or, well, it won't pass everything, but it'll fail on the other thing because we didn't refactor that other thing as well. So now we're on... we got another test that I guess we're failing on. So... I guess let's go look for this. I guess let's go figure out what's wrong with this. Okay, we made it past one more test, but we're kind of crawling along here. It's kind of annoying. So test index 13. Let's go look at test index 13 because maybe if we're lucky, it's you know, we're hoping that eventually the problems are going to be, like, not our fault. It's going to be, like, just the, so for here, we got, like, a 1 and 1, and a... Zero to 6, 0 to 2, this is 1, and now we're expecting 3, but we got 2 instead. So that to me looks like we have to seal. Looks like everything's working except we have to seal the result. So let's take that 13th result. Right, so this is the 13th result is right here. Let's steal this for a second. And it fails on both axes, right? It fails on both axes, so let's just steal that. And be like... let's take one of these out. Let's take one of these out. Let's take all these redundancies out. And zero out your range. And this one is, you know, ceiling is important. $24 items now. And now we're just gonna have to loop through this, aren't we? So just do that. Just say, you know, 4. So we're gonna go through all these little test indexes, and we're gonna do test index times 12, right? So test index times 12, right? 1, 2, 3, 4, 5, 6. Or hold on. 1, 2, 3, 4, 5, 6. Oh, my bad. There's only 12 things in here. And 1, 2, 3, 4, 5, 6. It's because we took those other things out a while ago. But yeah, let's just take this formula here. And okay. So we're also going to have to print off the test index as well. And I also see we didn't really do much here. We screwed that up. So we want to print off the test index that we're failing on. And the assumption is we're not going to fail in the first test index. So TI. Okay, let's give this a shot, see if we can. I just can't write code. Is that what this is? Oh, there needs to be a comma here. Okay. And I'm gonna have to do like 10 more push-ups before the end of the night, so once we can get this failing, then we'll see what needs to be changed. But I think it's just that we need to seal something. I think something needs to be sealed. So the test index is 1, so we can see the cluster size is like 0.42, whatever the heck. And we got like, yeah, if we look at this math here, the final value before truncation, right? So we want to take the whole formula, right? Before we do this make U32, we got to look at what it is before that, because I'm going to guess that it needs to be did we not even print off what we got? Did we like do all this work and then we just DI is what we're expecting. Let's change that around just a little bit so that we can see what did we get and what did we expect. And I'm assuming that if we look at that, we're going to see everything we need to see in terms of, yeah, I think we just need to do a simple little flooring or ceiling somewhere. So expected, sorry, got and expected. DI is what we expected, right? No, DI is what we expected. Sorry. Expected. Right. So we expected DI. We expected 3 and we got 2. So I'm going to guess that if we take the whole formula, if we take this whole formula, and we try to print off this, but we remove this make F32, right? So just take this like this, and if we print off this, before turning to integer. So before turning to integer equals %f \n and a comma before make integer, right? Before we make it an integer, %f, right? Float, yeah. So before we make it an integer, we're thinking that if we look at it, it's going to be something that should either round or it should seal. I'm not sure which one it should be doing. But let's look at the results and kind of make a educated guess, right? So I'm leaning towards sealing or flooring. So here we see that the cluster size, so we got 2.333, right? So the only way to get to that 3 that we want is to seal it, right? Because if we floor it, obviously we're not going to get 2. If we round it, it's still going to go down. So it looks like this requires a seal for this to work properly. Okay, so now that we know that, let's just add a seal, right? So, so over here, I think since we have the math libraries intact, we can just say over here, we can say, I think it would be called CLF. I don't know. Seal C99, right? So I think it would be called CLF, but I don't know for sure. Let's call it CLF. I bet CLF is the thing. I could be wrong though. Right? Seal float, that's the idea. Hello. How's it going? I like you.
I like you too. You want to hang out for a minute?
Yeah, just once I get this to a good stopping point.
Okay.
I gotta do 10 more push-ups before midnight anyways.
How dare you?
So, okay, so I think I got through... Alright.
It looks like stuff might still be leaking a little bit. There's a puddle.
Oh, no, that's probably just my shoes.
I really hope it's your shoes.
Because the toilet water is coming from the PVC pipes. Yeah. Okay, so we got this to end up back where it was failing again. So, yeah, we know that a seal is what we need in this formula, right? So, man oh man, to get this kind of mapping to our pixel perfect desires, There's a lot of things we gotta do, right? So this kind of is crazy, but okay, we know. Let's make sure. I think we have a macro for sealing, so let's make sure that we can look in here and we see seal F32. So now seal F32, does it return a? I think my seal F32 macro, like yeah, I think the polyfill. Let's go look at the polyfill for that. So poly OGL. I'm gonna guess seal F32 like takes a. It probably takes a float 32, but returns an integer. So seal F32. What do we call it? Match whole word is probably on. Match case is probably on. Yeah, so seal F32, right? It takes a float 32 and returns the int 32. Okay. So with that, because it's like that, that makes our lives a little bit easier, because with this, right, instead of just saying make 32, all we gotta do is replace it with seal F32, right? So, right, because they're gonna take the float 32, it's gonna seal it, and it's gonna return the integer, right? So, bam. Okay. So, what we're hoping is that we can get out of this testing hell, and that we're hoping to get meta group 2 for the failure. We're not hoping to get all tests passing just yet, but we're hoping that, hey, we got pretty far. We actually are now on the third group, right? So the third group, so we got to figure out, well, what are we running for the third group? What is the test function for the third group? And okay, so simplified. Let's go copy this and go find it. So simplified something something. So we got this conversion to work, I guess. Yeah. We got 2 to work. We got 3. We got 3 is failing. So if we go look for this function here, right? This function, we may find what's wrong with it, right? So let's go look. Let's go look. This is not the function. Oh no, this is the function. Oh god, crap. You're telling me we got all the way to here, and then we failed? So we're expecting 0, 0, and we got this 1, 0, huh? For test index 0, no less. Well, I guess let's go look at test index 0 and see what it is. Pretty damn simple, right? We got a 0, a 1. Where's the source? Oh, source X, source Y goes through this whole thing, right? So here's the range of the source. This is like a selection area, right? This is a selection area. And God damn, why is this so fucking hard? So I guess we need to recreate this problem as well, right? So this is the problem that's failing us. And so we got this 12 and 6. This is infuriating. So it's like okay, so we have to do look at Okay, so got my push-ups down. Let's go look at push-ups. This code here. So it looks to me that we're getting a very basic test case failing here. Let's look at the axis, right? So the expected versus what we got, it's failing on the x. So the x value is failing. It's like a 0 to 1 thing. And hold up here. Is this not completely diagonal? Is that not completely diagonal? That's completely diagonal, is it not? 0, x's are 0s, y's are 1s, dx, right? And so we're seeing asymmetry here. Let's go look at how we're calling it. The x. Sx and xy. Did we forget to add... Did we forget to add all the flooring that we needed for this function? Seems to me like this function must be asymmetrical. Because... Oh, wait. Sx is 1, sy is... Sx is 1. Okay, I got ya. So... we need to test with specifically these values, right? So, a large range to a small range, right? So we're going 0 to 11, 0 to 5, right? So like in our check our math kind of section, we know, okay, we're going, you know, the location that we're on is 1. We're going, you know, 0 to 11, and we're funneling down to 0 to 5, right? So 0 to 5, right? So from a 12 to 6, right? And the expectation is that this will still be 0. So we have something like this, right? So we have, you know, a 0, 1, 2, 3, 4, 5, 6, 5, right? And that's the output range. And the input range is something like this. 6, 7, 8, 9, and then 10 and 11, right? So if we chunk that up, right, we try to evenly space this to figure out what maps to what. Then we're expecting we anticipate this. We anticipate this kind of partitioning, right? We expect these ones to kind of map down to here. These values here, and then these pixels here are going to map down to these pixels, right? So, okay, right? So 1 on 0 to 11 range, right? So it's on this 0 to 11 range. And we're expecting that that the 0 and the 1 are going to map to the 0, right? That's the anticipation, but that's not what's happening, right? So let's oh, hold on. So if we're going to add this 6 and 6 is 12, plus another 6 is 18. And so we are going to expect that this third test case fails us. And then we're going to hope that we can glean some type of information that's going to tell us what's going on. What? So SX is 1. Expected is 0, 0, and then we're on 1, right? What do we got here? We expected a 0. And that's what we got. We better go look at our polyfill and make sure that polyfill correct. Let's make sure that seal F32 is seal native. Well, first of all, we're using seal F. I don't know if that changes it, but let's use seal F because seal native, right? So seal F, this float 32. And then after we seal it, we get this in 32, right? Yeah, so let's try that, because maybe we got some implicit type conversions of some sort, maybe. I don't know what's going on here. Because my little test here, my little proof of concept test, that's actually working out. Oh, hold on. No, it's not, because we're not going through all the test indexes, right? Okay, there we go. So now, if we give that a shot, we're going to see hopefully a failure on that third test, and maybe we can try to figure out what the hell's going on, right? Okay. 0, 1, and 2. Test index 2. Alright, we got a 1 on a 0 to 11 range. To a 0 to 5 range. We're expecting 0, we're getting a 1. Right? We're expecting a 0, but we're getting a 1. Because we have this one right here. And we're expecting to be down there, right? So we decided to seal. But maybe we need to I don't know what we need to do, but it looks to me that sealing isn't always the right answer, right? Now we could try to put this case first, right? So we already know the other cases are passing. We could try to put this case first. And then we could try to, like, floor it. Right? Because we see that, you know, floor F seems to be the answer here. And that'll get us somewhere, I'm sure. But I don't think it'll get us all those tests passing, right? I think that's not going to be the case. And also, we gotta... So let's try this out and see if floor gets all these little tests kind of passing, or if... I assume it's going to pass this first one, maybe, and then the other ones are going to fail, maybe. Yeah, so this is test index 2, so 0, 1, and 2. Alright, so... So, seal is important. Let's take this one and look at what that does, right? So, that is taking something from a 0, 1, 2, right? It's taking a 0, 1, 2. And, oh, that actually might give me some insight, huh? So this one is taking me from 0, 1, 2. And then we're mapping to... Oh, we're going up, aren't we? Mm-hmm. Zero, 1, 2, 3, 4, 5. Right, we're going, the second case, 0, 1, 2. The second case is going from the range 0 to 2, 0 to 2, mapping to 0 to 6. And what do we see here? We see that this is well, first of all, holy crap, these numbers suck. Well, first of all, that's just not... There's no deterministic way that I can see that mapping, right? Because, like, look at this, look at this. You see this? I got 1, 2, 3. It's not evenly partitioned. Like, if it's not evenly partitioned, I don't care. If it doesn't work on a per pixel level, if the math doesn't check out on a per pixel level, then I have no... Right, if it doesn't... Yeah, this is just a bad... Was this my example? Seal is important? So 0 to 2 range. 1 on a 0 to 2 range. So it's saying, well, hold on. It's saying that it's in the middle, right? We don't know exactly how to partition this, but we're expecting it to at least be in the dead center, right? That's what we're expecting. That's kind of, I think that's the idea, right? That we don't know how this partitions, but we're expecting once we get to here that we're going to end up somewhere in the middle. So I would say that for the seal is important, we should make another test case where we do this evenly, right? Because if it works out evenly, but it doesn't work out like this, then I'm not sure I care about this, right? Because I kind of understand why the formula wouldn't work, right? So if we have like a 1 in a 0 to 2 range, and we start out at 0 to 5, and we also expect a 3. So we'll call this seal even distro. So we'll copy this. And this one's easier, right? Because we go up to 5. And it's pretty dead simple how that works, right? So, right, we know that 0 can map to gets this cluster, 1 gets this cluster, 2 gets that cluster, right? That's pretty simple. So if it works for this, then I don't know, then I think we're good enough. I don't know. So we have 4 test cases now. So this is the right. This is where I'm trying to test out this algorithm kind of inlined. And so 6 and 6 is 12. 12 and 12 is 24, right? So 24. Okay. So now what I'm thinking is, if the seal with the even distribution works, but the seal with the uneven distribution isn't working, I'm going to say, well, screw it. I don't really care. So the seal with the even distribution is failing right now, right? But I bet if we put seal F back in here, that's going to go away. Oh no, test index 0 is failing now, huh? So 0 to 11. So here's what I think. I think that it needs to be a seal or a floor, depending on if we're funneling up or if we're funneling down, which is kind of weird, but I think that's what it's coming down to. Why don't we just mess around with round F? Why don't we just mess around and see what happens? But I don't think round would be correct either. Not from the numbers I was looking at. You know, I so thought I had this. Yeah, we're doing seals. That's right. We're using seals. Okay, what have we got here? Why is this failing? One on a 0 to 2 range, right? To a 0 to 5. 0, 1, 2, 3, 4, 5. And expecting a 3. Well... Actually, no. Because we're going up, we don't know exactly what to expect, right? I know that the formulas seem to work best with a 3, right? So, if we're upscaling, there's just some resolution we're gonna lose, right? So we expected 3, we got a 2, right? And this is for this test index right here. So we put in 1, and we expected a 3, we got a 2. I'm gonna say no. Actually, that's okay. I'm gonna say no. Definitely, that is okay. For that to happen, right? Because we don't know which one of these it's gonna pick. So it looks like picking the base kind of makes the best sense if we have to make that arbitrary decision, right? So that also means that over here, this 1 maps to either here, or something in here, or something in here. And so this 1 can't really... This one has no resolution to pick... Right, because we're flooring. We're already flooring. Right, because technically this would map to like 2.5. But we're flooring it, so this would actually be... This would actually pick a, not a 3, this would pick a 2. Right? But you think that it would be dead even, so that it would just round to 3. Anyways, let's give that a shot and see if what we fail on now. But yeah, it looks like ceiling. We got to think about terms of like information loss when we do this, right? I think that 2, so 0, 1, and 2. So simplest, this case is failing here. Okay, so we're going from here and we're funneling down. And we're expecting 0, but we got 1. So 0 right here, which means that we have a 0 or a 1, right? So yeah, we got 1, which gives us right here. So we got 0 to 11. 0, 8, 9, 10, 11. Then we got the output is 0 to 5. 0, 1, 2, 3, 4, 5, right? And so it should be pretty obvious that we should be mapping this to here, right? And it's not what we're getting. You can see 12. The cluster size is 2. That's good. And before we make it an integer, we got a 0.5. So this would suggest there's arbitrary choices here. When we upscale, when we downscale, however, I think we need to be flooring. Let's go look at what we get wrong when we floor. Right? When we floor this, what is the result? And is it a result that we can, like, tolerate? Is it a result we can tolerate? Is it a result that makes sense, that can make sense? So test index 1 fails, so 0, 1. So the seal is important. And expected 3, we got 2. So we're expecting 3. And we got 2. I'm going to say rounding actually makes the most sense, right? Right, so the reason it can't actually distribute like this is because one pixel, this pixel is getting 2. This one is technically getting 3, right? This one's getting 2 over here, right? That's not an even distribution. Now, the thing is, we're saying the thing in the middle should actually get, you know, all of it. I'd say when we're going up, we want to seal. When we're going down, we want to floor. But that just seems kind of hackish, doesn't it? That is what the results kind of suggest, though, right? Like, we want that to get exactly to 3, like, exactly into the middle, which could make kind of sense. Like, we don't know if it really should really grab for 2. We know that it should grab for something that 0, 1, and 2. Right? It should grab the third. It should grab the thing in the middle. I'm gonna say so we fail test index 1 here. test index 1 here, 0, 1. This is failing here. Now if we seal it, it will it'll fail on something higher. So 2 it fails on. So this is 2 right here. Let's put this over here for a second. See if that if it still fails on the last one. Three. So 0, 1, 2, 3. So it's failing on the third. And then if we make this a floor, will it fail on like the first? Not the first, but so here's what I think. If, so I'm thinking that is the same exact formula, but I think we might be able to get everything to pass if we just do like one of them seal, one of them's floor. I don't know which one's which. That is ugly though. That's not a very nice solution, is it? To change it to a seal or a floor, depending on if you're upscaling or downscaling. So let's do seal F, and I don't remember which one it should be. Floor F. Let's try that again. So we're pretty sure that some of them pass with the seal, some of them pass with the floor. That was our guess, right? Yeah. So the direction matters for this mapping with the way we're doing it. Right, so we got the seal is important, and we got the 0 to 2 and the 0 to 6. We got that 1 to map dead in the center. But that is kind of ugly because, right, we have this, like, else statement in the logic, right? We got a branch. and how we're mapping it, we got a branch in how we're mapping it, right? So, it does seem that that works, though, so... So... Error to do. Make a floor or seal... So let's make like a floor command that kind of depends on if we're upscaling or downscaling. So it takes like a third parameter, and then it has a branch in it. And it's not the best way to do this, but I think that that is the current solution I have. And we just want to get something working, right? So let's not fret over the fact that, you know, it doesn't quite, that it's getting ugly. The code is getting ugly. We don't have the most elegant situation here. But it seems that, you know, if you're going the upscaling direction versus the downscaling direction, that does make a difference. So, anyways, I'm going to get out of here for now. This is video 144, so 142, 143, 144. Yes, I'm out of here.